Thank you so much, Raya, for the introduction, and thanks also to the committee for inviting us to give this presentation. So this is, as Raya mentioned, joint work together with Shonali, who's also here, and Carl, who couldn't join us. And what we're trying to do with this work is to look, as Raya mentioned, from the bottom up at the intersecting inequities in energy consumption, access to decent living standards, and then looking forward at risk of climate change exposure. And we chose 3 countries to work with, which are Ghana, India, and Brazil, and we hope to expand this to further countries in the near future. As Raya already mentioned, this is ongoing work, and we're really open to criticisms, comments, or feedback, or questions. So please do feel free to interrupt during the presentation, put your hand up, or just jump in, and we can take the question. So let's begin. As I already mentioned, we conduct the analysis in Brazil, Ghana, and India, 3 countries with different living standards, geographies, and climates. These countries also exhibit or report relatively low GDP per capita. So on the right-hand side, you can see comparisons against Austria, where I currently am, and the United States, and the 3 countries that we are studying, Brazil, India, and Ghana, below. At the same time, looking back, these 3 countries also report relatively low per capita CO2 FFI emissions. So here again, looking back to 1850, we can see the United States and Austria, and then our 3 study countries, Brazil, India, and Ghana, in terms of contributions to the current climate crisis. Finally, despite having a low per capita GDP and low historical emissions, these countries are among those facing moderate to high national climate change vulnerability, which is taken from the University of Notre Dame Gaines Climate Vulnerability Index, as you can see on the right-hand side, with Brazil moderately vulnerable, Ghana and India more severely vulnerable. Okay, going ahead to our research questions. So we know from the aggregate data that these the effects of climate change and poverty intersect at the aggregate level in these countries. We want to understand how, where, and for whom. So we have 3 subordinate research questions: how equitable is access to and consumption of affordable and clean energy within these countries? What is the level of access to decent living standards in comparison to absolute poverty measures? And how is this distributed across the populations? And finally, bringing these 2 things together, along with climate exposure risk, which population segments within these countries are particularly vulnerable to the effect of climate change, and where are they located? In terms of data, we use household survey microdata, which describes aggregate expenditures across different goods and services. For example, consumption of clean and unclean fuels, private mobility fuels, and also describes household characteristics and access to services, things like home composition, family demographics, and ownership of different assets. For each country, we currently have processed and standardized 2 years. So in Ghana, we have 2005 and 2017, India 2002 and 2011, looking forward to expanding that with the new data coming out this year, and Brazil 2002 and 2017. So part of this work is actually homogenizing these 3 and more country level data sets. So I'll get back to that towards the end of the presentation. But basically we have one standardized data set which contains every country and observation in a tidy format with the exact same variables. We also use a global spatial climate exposure risk data set, which was developed along with, or led by a colleague here at IIASA, Ed Byers, and many others. And this data set describes risks to the population through 3 different sectors: the water sector, energy sector, and land sector, under different temperature and population trajectories. And for this work, we take the exposure in the year 2030 under an SSP2 socioeconomic pathway, and assuming a warming of 1.5 degrees. So with the data behind us, let's dive in to what we found. The first thing I want to talk about today is the differences in energy consumption or fuel consumption at the household level. So here we're showing 6 different plots. For each country, we have both survey years. The upper panels are the earlier survey years, the lower panels are the later survey years. The y-axis describes the gigajoules per capita final residential energy consumption, and the x-axis describes the per capita expenditure deciles, which these average demands, average consumption values correspond to. Energy consumption is separated into 3 broad categories. We have household dirty, household clean, and fuel oil mobility. Now, household dirty are basically the fuels that the WHO recognizes as not being clean. And in this case, they're largely biomass. Household clean clean fuels used within the household, and fuel oil mobility is essentially petrol and diesel for private mobility use. And what we can broadly see in this figure across the deciles is a substitution from the biomass fuel consumption or dirty fuel consumption to clean fuels in the upper deciles. If you were looking at this from a useful energy perspective, so the step after final, you would actually see that there is a substitution effect occurring, but also increased energy consumption occurring as well. And you can't see that here because the efficiency of biomass is quite poor, and this masks that increase in clean energy consumption among the wealthier households. But more drastically, we see this sharp rise in private mobility fuel oil consumption among the very highest deciles, for example, in Ghana and India. And indeed, I had to have a look at this twice. I was wondering why it jumped so much in Ghana, and there was a massive increase in private car ownership between these 2 survey years. And in Brazil, we can see this trend growing sharper over time between the 2 survey years. I must note in Brazil in 2017, we're still working on imputing the biomass fuel consumption, so that's actually not shown there. Okay, let's go on to the next figure. So now if we look beyond consumption trends and we look at affordability as well, what this figure shows, and I'll walk you through it, the y-axis is the share of annual per capita expenditures on clean energy relative to total household expenditures. So you can think of 10% being a threshold of affordability that's often used. The x-axis shows the mean per capita final clean energy consumption in gigajoules. And the points represent the 10 different deciles that we are aggregating to, and then they themselves are given shapes to give you a feel for what this means across countries in terms of the per capita purchasing power parity expenditures. So in general, we can see in Brazil, the upper deciles are wealthier, for example, than in Ghana. But what I want to draw your attention to in this figure are 2 kind of distinct trends that are occurring. If you look at Ghana and India, which are the figures in red and orange and blue and light blue, what you can see is that households are not breaching the unaffordable level of annual expenditure for clean fuels, right? So they're up to a maximum of around 7% of the annual expenditures. But at the same time, you can see that this is occurring at very low levels of consumption overall. So the fuel may appear affordable. With certain multidimensional metrics, you might think that this is an affordable level of fuel consumption. It's actually suppressed due to lack of access. So poorer households in these 2 countries may not be spending more than 10% of their household budgets on fuels, on clean fuels. But this is not because the fuel is affordable, it's rather because they haven't got access to fuels in aggregate terms. In Brazil, we can see a different trend. In Brazil, we can see that as a population generally gets wealthier, as access improves, the burden amongst the poorest households is quite high. It's growing over time. So the poorest decile is spending more than 10% of their budget on fuels, on clean fuels in 2002, and this is almost reaching 17% in 2017. So basically what we're seeing is poorer households either face low access, and thus the affordability issues are masked, or once they have access, they're facing high costs, and then you can see the affordability issues appearing. Now we can look beyond fuel consumption and affordability at the decent living standards. And I'm not sure how familiar you all are with these, so I'll just go through them briefly. If you have questions, please do interrupt. The decent living standards are material requirements or prerequisites for human well-being. So they link back to notions of basic human needs, Doyle and Guth, and they describe the material needs, and they have been translated also to energy needs here by colleagues and other scholars. In the table on the left-hand side, you can see how the decent living standards are grouped into different needs groups and how these needs groups have their own dimensions. So, for example, the needs group of shelter has dimensions of housing, thermal comfort, and clothing. And the heuristic is our attempt at mapping the decent living standards needs groups and dimensions to the available microdata that we have access to. So, for example, for housing, we consider a household to have achieved a decent level when they have a solid construction and maximum 2 persons per room. For thermal comfort, we believe they have achieved the requirements to meet decent living standards when they have the requisite thermal comfort devices. So this is one kind of contrast in decent living standards. It's the material requirements, not necessarily that the households are achieving that functioning in the capabilities language. For some of the measures we can't adequately cover them in our data. For example, clothing is not able to be covered in our microdata, and neither is access to nutrients or roads. So with that behind us, we can look at the actual data. What the figure on the right shows is, again, by per capita expenditure decile. On the x-axis, we show for each decile the share of that decile with access to that decent living standard dimension. The different colors, again, represent the different countries that we are analyzing, and generally darker colors are the later survey years. So a few things we can note right away is that it's very interesting that health insurance is typically quite low, even amongst wealthier households, except for in Ghana, where there has been a progressive health insurance scheme put in place. In general,
can I interrupt just quickly just now, because Ghana
definitely
has universal health insurance. I think that's the only country. Yeah. Right. Yeah.
Exactly. So that's already showing the disconnect between traditional measures of modeling, for example, with wealth. Right. There are ways of provisioning of these living standards that don't necessarily require aggregate wealth or aggregate GDP increases. So, for example, Ghana has the same level, or lower deciles in Ghana have better health insurance coverage than the higher deciles in Brazil. So again, this figure basically shows how even amongst the wealthiest households in Brazil, we have deprivations across distinct decent living standards dimensions. And what the solid and circular shapes show is it's a kind of a absolute poverty level proxy or threshold, right? So from when the circle is filled, these are above absolute levels of poverty. Below that circle, they're below absolute levels of poverty. And what we can see is even amongst those households that are above, let's say, a poverty threshold, we can see, for example, in Ghana, also in India, low rates of access to storage of foods, for example, ownership of fridge and freezer, low rates of clean cook stove ownership, etc. So there's a lot going on in terms of household multidimensional deprivation that the absolute measures that are available to us and typically used don't show us. And this can be done using publicly available microdata. It doesn't have to require a bespoke survey. Okay, so now we can move ahead from decent living standards to how we actually combine the decent living standards dimensions with climate change exposure risk. Here what we do is we have a spatial data set that describes climate change exposure risk for different exposure channels. So for example, for the water sector, and you can see here we have the admin level, we have cells where one cell is one spatial aerial unit. We have whether it's urban or rural, and we have for every cell the total urban or rural population and the total urban or rural exposed population through a given exposure channel. In this case, it's water. We can aggregate these at the admin level to calculate the total exposed populations or the share of exposed populations through these different exposure levels that are living in urban and rural parts of that admin level. That's our starting point. Then we take the household microdata, and within that microdata, we can actually determine the share of population in each admin urban rural group that's belonging to each decile in the country. So here, for example, we can see in Andhra Pradesh, in terms of all the rural population, 12% of the rural population are in the highest decile, 2% of the rural population in Andhra Pradesh are in the lowest decile. So as you can probably tell by now, we have overlapping information. We have the same admin area. We have urban and rural rates of populations living by decile, and we can combine these two things to get a first understanding for the exposure risk to climate change exposure across the deciles in each country. And this requires us to assume a homogeneous distribution of population within every rural urban admin regional group. Obviously, this is a limitation, but it's a first step in disaggregating deprivations across wealth groups and disaggregating rather climate exposure across wealth groups. This is how we've done so. So basically what you can see here, when you combine how many people are exposed in rural and urban areas with what percentage of these people are in each decile, we can determine the total exposure rate of each decile to that specific pathway of climate exposure risk. So you can see here, for example, in India, in 2011, the lowest decile, 35% of this population is exposed to climate change risk for the water sector, whereas a bit more than half of the highest decile are exposed. I'm sure you'll have questions there, but I'll move ahead now because I can't see at the moment.
Yeah, I think it would fit better for the discussion. So the question on the measurement of the DSL, yeah.
Got it. Okay, so what can we do with this? Well, once we've put these two things together, we can describe the share of each decile exposed to climate risk or risk of climate exposure for each of the different sectors. And as a reminder, the sectors of exposure are shown on the right-hand side here. I hope you can see this. So here we have, for example, in the water sector, it's an aggregate of water stress, groundwater stress, etc. For energy, we have heat stress, cooling degree days, and hydroclimate risk in the land, crop yield change, agricultural water stress. What this graph shows us is the x-axis is the average DLS deprivation within each decile. So this is, again, a first pass attempt at determining aggregate deprivations using the decent living standards. I mean, they're not reducible, so each one is important in itself. But for visualization purposes, we just take the average deprivation across all the dimensions and get one number for every decile. And the y-axis shows the share of that decile facing climate exposure risk, which is what I showed you in the table earlier, the final table. So when you put these two things together, what you can see is that the larger shapes are the wealthier deciles, and the circles are the poorest deciles. So what's immediately interesting is that in the water and land sectors, typically, except for in India, the wealthier deciles that are less deprived, so this is a wealthier decile in Brazil, it's less deprived, but has a higher share of the population in that decile facing climate risk than the poorer decile in that country. Similarly, in Ghana, we can see that exposure through the water sector is more sharply concentrated amongst the wealthier deciles who are less deprived than the poorer deciles who are more deprived but are facing less of that climate exposure risk. It's again different. So while the patterns are a little bit similar between water and land, and energy is quite different. In energy, in Brazil, it is the poorest deciles that are the most vulnerable to climate change exposure through the energy sector, where basically half of the poorest decile is vulnerable to this aggregate sectoral risk. And in India, it's quite flat. In Ghana, basically the entire population is vulnerable to climate exposure risk through the energy sector. And then we also have divergent trends. So for example, in the land sector, we can see that in India, exposure through the land sector actually increases for the lower deciles, who are also more deprived, whereas in Ghana, it's the pattern of opposites. Obviously, there's an interaction between the human geography of where these people live, where the deciles live, and where the climate exposure is occurring that motivates actually further work that we're hoping to do. So now we can move ahead from looking at which segments of the population are facing the climate risk to where they're located. So the figure on the left shows 3 maps for every country that we have explored. The maps describe the aggregate water, energy, and land sector climate exposure vulnerability. And this is a rudimentary indicator. Basically, what we've done is we've aggregated for every cell the DLS deprivation and the climate exposure risk, where 1 indicates incredibly high DLS deprivation, incredibly high climate exposure risk, and 0 indicates low DLS deprivation and low climate exposure risk. And this sort of collapsed scalar is disaggregated on the right, where you can see what it's comprised of. So the right figure shows kind of 2 different scales that are then combined. So the right figure shows increasing exposure, which is moving towards the pinkish color, or risk of exposure, and the x-axis indicates the increasing deprivation. And when they combine to a kind of dark purple are the population that are highly exposed and highly deprived, which are aligned with the purple on the figure on the left, which are close to 1. So what we're trying to do with this analysis, the spatial analysis, is to understand at a subnational level where the sharply vulnerable population lives. And vulnerability is defined as deprived of decent living standards and facing high climate exposure risk. So where do they live, and under what and through which channels of climate exposure risk are they most affected? And you can see it's quite different across the different countries in terms of which sectors affecting the population in which parts of the country. So again, this could be useful to understand, for example, where to look further in developing policies, specifically to address land sector risks versus to address water sector risks. So I'll move ahead. I think we might come back to this in the question time to just go through some key findings so far and then our next steps. So looking back to our research questions, so far we can say that access to clean energy and consumption is severely inequitable. Poorer households face both limited access, and when this access improves, unaffordability challenges appear. Second of all, we can see that access to decent living standards is quite heterogeneous, and even richer households can suffer deprivations that are hidden by absolute measures of poverty. Interestingly, we find that when we're bringing together climate exposure, risk, and DLS deprivation, we find that wealthier and less deprived households are actually typically more at risk of exposure through the water and land sectors. And we're speculating a bit about how this could occur due to urbanization and the demands placed upon the local environment where populations are concentrated. But we want to look at this further. Whereas risk of exposure through the energy sector is more concentrated amongst those who are more deprived. So there's a clear trend. The more deprived the household is across every country, the higher the risk through the energy sector to climate change exposure. Finally, if we focus specifically on the population that is deprived, and whether you use an absolute measure of poverty or you use some DLS deprivation threshold, we can see here that we can identify the segment of the population that is facing the intersecting risks of climate change exposure, DLS deprivation, and energy unaffordability. And we can look at this in terms of wealth levels. We're thinking about policies targeting this population, but also where they live using the spatial analysis. So those two things together could be combined to explore different policies and interventions that could address this acutely vulnerable population. And this then brings me to our next steps and what we're doing moving on for this analysis. So as I mentioned, the paper is currently in progress, and we're hoping to get this wrapped up soon. But we're also in parallel processing and standardizing a lot of data from many different countries, 20 countries in N years. So it's kind of like an IPUMS, but specifically for energy access or energy-related data and decent living standards data in global South countries. We're looking forward to critically examine how we can merge this microdata with new climate risk data sets and further explore and explain the differences and some of the counterintuitive findings we've uncovered in our work in terms of who is at risk of climate exposure. And finally, as I just mentioned, looking at which segments of the population are at risk and also where they live can help us develop and evaluate adaptation policies addressing this population, and more specifically look at analyzing provisioning systems that improve access to decent living standards and thus mitigate the risk to climate change exposure these populations face. So I'll stop there and hand back to Raya to moderate this.